Hi students, I welcome you all for the sessions. This is the continuation class on chapter 2. So that is the part number 3. So today we'll be going to discuss on functions, right? So based on functions, we'll be going to solve the exercise that is 2.3. So in our previous classes also mentioned about the functions, but today will be in detail. We'll be going to discuss about the functions, right? So the forget about the previous definitions. Now we'll be defining the functions, redefine the functions as correctly. Okay, what is a function? Suppose I'm saying here two sets a and b. So I'm saying he a to b. Okay, I'm saying from set a to b as a function relations. Okay, I'm saying from set a to b as a function relations. Then I will be write in a symbol that a to b. So means what? This a to b is having a function relations. So this symbol is called what? A to b is having a function relations. Now, so this function will be denoting by the term that is called map. So we'll be always using the terms map or mapping to denote the functions. So you just remember of that map and mappings where it comes. So it comes in the functions. Mapping means what? Two sets are there. We are mapping these sets. Okay, we are mapping the sets. So this is the meaning of that. Now we'll be understanding that. So we'll be understanding that what is the functions. The functions already we have defined that function is having a single image relations. So single image relations. When we are comparing in a relations, okay, when we are comparing a relations, then it is having a single image. What is the meaning of that? So we know about the relation, right? Relations means suppose two sets are there. Okay, 1 2 3 4 and 5. So here another set is there. So 1 2 3 4 5. So one is relates to 2, okay, by some condition. Okay, and then 2 is relates to 3, and 3 relates to 4. So condition here, these values, these are the first values. Then I'm writing here x, and these are the y values. So y is what? Y is x plus 1 here. Okay, 1 plus 1 2, 2 plus 1 is 3. So these are the matching. So then we can write here the relations. So 1 2, okay, the relations as a Cartesian product, right? Relation is nothing but a Cartesian product of the subsets. So 1 2 2 3. So 2 3, and then 3 4 and 4 5. So 5 is not having a relations because the 5 is not if you 5 is not having a relations because 6 is not here. So therefore the 5 is not a having relations. Therefore this set we can say as a this relation is this relation. Suppose you say this is set A and set B. So it's function A to B. So function A to B is not having a single image. So means because here phi is not having a relations. So there is no match with the phi. Therefore we can say as this is not a function relations. This is not a function relation. This is not a function relation, we can say. So why it is not a function relations? The phi is not having relations relation. Therefore we can say this is a this is not a function relations. And one more is that, so one more definitions, the if from the first element, the function relation always will be start from the first element. Okay, suppose here the square of the numbers are having, so y is the x square and this term is x. So 9 4. So this 9 is having two relations from the first set. So minus 3 and plus 3. This is minus 2 and plus 2. Right, square minus 2 square is also 4 because the negative of square is what? Positive. So these are having two relations. Okay, the first set contains a two relations. Contains a two relation. Therefore, this is also not a functions. Therefore, we can say that this is also not a function relation. Okay, so this is also not a function relation. This is not a function relations. When we can say a function relations, so function relation is having only single image. So 1 2 3 here, 1 2 3. So okay, this one because we can say as a this is a function relation. This is the function relation. Only one relation is having from the first element. Only we are having the one relation from the first set. Okay, defining the proper definition of what is the definition of functions. Okay, we'll be going to define the definition of a function. A relation from set A to B, from set A to B is said to be function, is said to be a function, is said to be a functions will be denoting by small f's if every element of, okay, if every element of set A has one and only one image in set B. Set B. Okay, now you understood this definition, right? So it is having only one relation from the first set to the set B. Now will be, so how we can write this mathematically? So A and B, two sets are there, and element of A is A and B is B. Okay, we are writing A, B. So A, B are both are belongs to function. Okay, A and B are belongs to function. So now mathematically we can represent okay, A to the B. So A to the B is having function relations. Now we'll be considering some example. Okay, we'll be going to discuss some example. Let n be the natural numbers. We know that n is the natural set of natural numbers, and the relation is defined by x comma y. Y is having 2x. So x and y are both, x and y are belongs to n. So in this case, what is the domain and codomain and range? Okay, what is the domain and codomain and range of the relations? Is this relation is a function? Is this relation is a function? Okay, we have to identify this relation is a function, and domain and subdomain also we need to find. So here domain is the domain of R is a set of all natural numbers. So domain is set of all natural numbers because it given is natural numbers, natural number or continuous. So the domain is a set of all natural numbers here, all natural numbers. And what about the range? The range is also a natural number, right? Range is also a natural number. Okay, range is also a set of natural number, and domain is also, codomain is also set of natural number. Okay, we don't know about what is the range and which contains how much of elements. Therefore we can say as n is a set of natural numbers, therefore domain is also a set of natural numbers, range is also a set of natural numbers, and codomain is also a set of natural numbers. Now we'll be seeing the another example. So here the relation is given. So relation is given 2 comma 1, 3 comma 1, and 4 comma 2. So second one is given as r is equal to 2 comma 2, so 2 comma 4, 3 comma 3. Okay, third one is given r is equal to 2 comma 1, 1 comma 2, sorry, 1 comma 2, 2 comma 3, 3 comma 4, and 4 comma 5, and 5 comma 6, and 6 comma 7. So we need to identify this relation is containing the function relations. So here all here 2 1 3 1 4 2, so it is having single image. Okay, it is having single image. So now this second example here, 2 repeats, 2 is matching with the 2, 2 is matching with the 4, means from this, from the first set, these are the first element, right? The first set we are having 2 2, 2 is repeating. So from the two matches are will be there. Okay, so first element is 2, first element is 2, so it is first element is repeating. Okay, first element is matching with the 2 and 4. So from the first set, so two relations are there, therefore we can say this is not a function. So therefore this is not a function. The second one is a not a function, not function. Okay, what about third set? Third set 1 2 2 3 3 4 5 6. Here all values are unique. Okay, the first elements are not repeating. The first elements are not repeating, and we can say that this is this relation is a function. This relation is a function relations. Okay, understood. Now we will be seeing another example. Suppose if a natural set of natural is given, and function f of x is equal to 2x plus 1 is given. So f of x is equal to 2x plus means what? F of x means what? It is a y. So y is equal to 2x plus 1. So we are having a set x. First element is first set is x and second set is x 2x plus 1. 2x plus 1. Then so if we put the value of x is equal to 1 2 3 4 5, 1 2 3 4 5 6, then 2x plus 1, what will come? It comes as 3 5 7 9 and 11 13. Okay, in this value we have to put x is equal to 1 2 3 4 5. Okay, so now so this is also, we can say, as this is the function relations, right? No values are repeating, from the first element, therefore we can say this is a function relations. Okay, now we'll be going to discuss some functions and their graphs. Okay, there are some functions and their graphs. Some functions and graphs. Okay, suppose the first condition we'll be going to discuss here. We'll be going to discuss So the first condition we'll be going to discuss is identity function. Okay, identity function. Identity function. Suppose we say R is a set of real numbers. So this is a set of real numbers. So real numbers is a function relations. Then y is equal to f of x. Y is equal to f of x is x. Okay, then when y is equal to f of x is x. Okay, here means what? Y is equal to x. Y is equal to x, and such type of function is called identity functions. Okay, when so we are having a function relation of real number, when we are having a function relation of real number, and x is equal to y, and we are getting x is equal to y, such type of relations are called identity functions. So identity functions, and the function is called identity functions, and the what will be the domain and range of the values. So here, domain and range of the values are real number only. Domain and range of the functions. So domain of a function and range of functions is a real number only. Okay, and the graph, in the graph we will be getting a straight line. Okay, suppose if we plot a graph, this is positive x directions and this is negative x direction, and this is positive y and this is negative y direction. So negative will be a dash. I am giving a dash. So here domain range, domain of the function relations and range of the function relations is a set of all natural numbers. Suppose here in this identity functions will be getting a straight line. We'll be getting a straight line which is passing through a origin, These are plus 1, plus 2, plus 3. These are the minus 1, minus 2, minus 3, and these are the minus 1, minus 2. These are the plus 1, plus 2 in the y directions. We'll be getting a straight line passing through the origins. So such type of relation called as identity functions. Now we'll be seeing the second function is constant functions. When we are saying a constant function, so constant function means what? We are doing a function relations of a real number. Okay, function of real numbers, and if y is equal to constant, if we get y is equal to, y is nothing but what? F of x is equal to c. If we got the constant term, then such type of function is called as a constant functions. And what is about here the domain and range? Okay, here the domain is, domain of the function is R, domain of f, you write. Okay, what is the range? So range of function is constant. Okay, range of function is constant. But in previous cases, what is the both the domain and range of the function is are set of for real numbers, and here the domain of the function is r, and range of the function is constant in a constant functions. Okay, in such cases, in these cases, we'll be having a graph. We'll be having a we'll be having a graph, a parallel line to the x-axis, a parallel line to the x-axis will be get. Okay, this you understand, this point you have to remember. Okay, now the third function is polynomial functions. As the name itself, polynomial means what? So we are having a polynomial equation a1x and a2x squared. This is the polynomial equations. So therefore this is a polynomial function we are calling the polynomial equations. And here, so the function y is in the terms of y is in the terms of polynomial equations, a1x a2x square. Okay, so this is the polynomial equations, and suppose I am giving example of the polynomial equation here. F of x is equal to x cube minus x square plus 2. This is a polynomial equation, right? And another equations I will also write here, x g of x is equal to x to the power of 4 root 2x. So this is also polynomial number. So, and this type of equations are not a polynomial. I will give you example here. X is equal to 2 by 3 and 2x. This is not a polynomial functions. This is not a polynomial functions. Okay, this is not a polynomial functions because it is given the n the power is given in a fraction. Power is in a fractions. Now, we'll be going to discuss some examples. So examples, okay, examples of the here equation is given. So the function relation, some example we'll be going to see. Function relation is given, means y is equal to f of x is equal to x square is given. So here x is belongs to r. X is belongs to r. So means what here we have to put the value of real numbers. We have to put the real numbers. Suppose the real number is negative and positive also. Positive also 0, 1, 2, 3. And what is the x square will be here? So x square will be 16, 9, 4, 1, 0, 1, 4, 9. Right. So this one we have to plot in a graph. So this one we have to put in a graph. This is x, x dash. So this is y, y dash. Okay, here 0 is there. If we put the minus 4 negative axis, okay, minus, suppose here minus 4 is there, then we'll be get 16. So this is y, right? Y, in the y we will be getting. So respective of here, suppose say here 16 will be there, and minus 4, okay, over minus 3 here having a 9, and then we are having here minus 2, 4, and here for the positive value 149, suppose 149, here 149. Okay, like this graph will be get. Okay, like this graph will be get. Okay, you just try this one. Okay, for the minus 4 here we are having minus 4 means in x-axis minus 4 here, and these values are in y-axis. All values are positive, therefore here we will be getting the graph like this. Okay, okay, this is understood now. Also you can try for other problems in access in given in the textbook. So this concept is very easy. Okay, and now I will be solving some exercise problem. So one more functions we'll be going to discuss here, uh, rational functions. Okay, fourth function is rational functions. Okay, rational functions means what? As the name itself, rational means what is, which is in the ratio f of x to the g of x. Okay, function is called as rational functions, and where this the condition is that g of x is not equal to 0. Here g of x not is equal to 0. If g of x is 0, then it is not a rational function. Then 1 by 0 is equal to infinity. There is no means sense of the relations. Okay, then another function. So another function is modulus function. So in rational functions, we'll be getting the graph. we'll be getting graph like this. Okay, we'll be getting the graph like this. Okay, in the rational functions we'll be getting the graph like this. Okay, and what about in polynomial functions? Polynomial functions. So polynomial functions will be getting the graph. We'll be getting the graph like this. Okay, we'll be getting the graph. So for any relations will be given, the graph will be getting like this. Okay, just remember that. So here I'm identity relations. I'm getting a straight line which is passing through the x-axis. So here straight line in the class. So in constant functions, the straight line will be getting parallel to x-axis. In polynomial functions, like this graph will get, and in the rational functions, we'll be getting the relations like this. We'll be getting the graph like both sides here parabolic. Now one more function is remained, that is modulus functions. So modulus functions means what? So modulus function, this is the last functions. Okay, modulus function. So modulus functions means what? So suppose we are writing a negative number of modulus. So modulus functions will be written in a this symbol, this symbol. Okay. So any negative number of modulus is positive only. We'll get positive. Any negative of modulus functions will be the positive. And here the function, so f of x is equal to modulus of x. F of x is equal to model of x, and here we are having a function relation of real numbers. Then how we can write two conditions. Here we are having a two condition. F of x is equal to when y is equal to x, then when only when we'll be get y is equal to x only when x is greater than or equal to 0, and we'll be get minus x only when the x is less than 0. Okay, when y when x is greater than equal to 0, y is equal to x will be get. When x is less than 0, we will be having minus x. So in this case, we'll be having modulus functions, we'll be having a graph, like this. Okay, we'll be having a graph, we'll be getting a graph in this manner. Okay, we'll be getting a graph in this manner. X dash x y dash. You just remember how we'll be getting the graphs in the different functions. Okay, modulus functions will be getting like this graph. Understood? Now, and the another functions also we are having, that is a signum functions. Okay, signum function. So signum functions. So in signum functions, we are defining a function relations for the real numbers. Here we will be getting the three different conditions. So y is equal to 1 when x is greater than 0. Y is equal to 0 if x is equal to 0, and y is equal to minus 1 will get if x is less than 0. You just remember what in the signum functions we are have three condition. In the modulus functions we are having two conditions, and we are having graph structure is like this. And you just remember all the statement of these functions, and with respective graphs you have to remember. Okay, so you have to remember how we can write here uh, the graph of the signum function is will be getting like this. Okay, x dash will be getting y dash will be getting the graph. So we here y is equal to 1, and in this direction so we will be get, okay, here plus 1 and minus 1, and here we will be getting a minus 1. Okay, like this graph we will be getting in the signum functions. Okay, next we'll be going to the some algebra of the next we'll be going to the concept of algebra of real numbers. Algebra of real numbers. Next we'll be going to the concept of algebra of real numbers. So algebra of real numbers means here we will be having the relations between the functions. The relation between the functions. Suppose you say f of x and g of x. These are the functions. So we are having relations between the functions in terms of addition, and subtraction, and then multiplications. Okay, here the first we'll be going to discuss addition of two real numbers. Addition of two real numbers. Addition of two real numbers. So suppose if x is belongs to, or x is a here x is a function relation to the r, and here f is equal to here the first function, and second function is that x is also belongs to r. Okay, here we are having two equations, that is two functions, that is f and g. Both are function relations. Both are having a function relation. Suppose when we are adding this f plus g here, f plus g with respect to x, then how we can write this? F of x plus g of x, f of x plus g of x. So these f of x plus g of x, so g of x, this f of x plus g, f plus g of x is also belongs to f plus g into x is also belongs to function relations. Okay, then we are having here f of x plus g of x for all value of x belongs to x. Now we'll be going to discuss the second condition, that is subtraction of a real numbers. Subtraction of a real number. So as the name itself, here we are having two relations, f and g. So here x is belongs to r, and here x is also belongs to r. Then we are writing a relation f minus g into x. Then we can write this relation as a f of x minus g of x, right? F of x minus g of x, and here small x is belongs to capital X. Next is multiplication of a scalar. Next is multiplication multiplication of two real numbers. So same here, the statement is same here. So multiplication means f into g of x. Then we'll be getting here f of x into g of x. F of x into g of x. Understood. And one more condition, quotient of real numbers. So quotient means which is in the divide form. Quotient of two real numbers. So here f of g we are having. So f of g into x. Then we can write this relation is a f of x to the g of x. Okay, this is the quotient of two real numbers. Okay, now the concept is over. We'll be discussing some example. We'll be going to discuss some example. Then you will understand the meaning of a function. So example one here. So f of x is given x square. So means it is y. So and the another function is given here, g of x is equal to 2x plus 1. Okay, then be the two real functions, find. So then we have to find, now we have to find all. So then what is the value of f plus g into x? Okay, so g into x, so f of the, so when we are f of f plus g into x is what? F of x plus g of x. We are adding both functions. So we are adding both functions. F of x is given what here? F of x is given x square. F of x is given x square plus 2x plus 1. 2x plus 1. Okay, this is over. Next, we'll be going to subtraction. What is the f minus g of x relations? We'll be having f of x minus g of x. So what is f of x is given? X square. So x square, and here g of x is 2x plus 1, then minus is here, then both term will be get minus. Okay, what about f of f into g? So f into g of x. So f into g is what? F of x into g of x multiplications. Then we are having x square into 2x plus 1. X square into 2x plus 1. Okay. Next, we'll be going to discuss f of quotient. So f of g into x is what? f of x divided by g of x. F of x is what? X square divided by 2x plus 1. So here this here here if value of x is equal to minus 1 not equal to minus 1 by 2, if value of x is minus 1 by 2, the below term is will be at 0, and we are having the condition is below term g of x will not equal to 0. Okay, this is over. Now we'll be going to discuss some exercise problems. So I just make the copy of the exercise problem here. 2.3. Okay, we'll be solving this exercise. So here first question is given, which of the following relations are functions? Give the reasons. If it is a functions, then determine the domain and range of the functions. So here the first problems, you just see the first element. Okay, first element is not repeating everywhere. So the first element is not repeating. Okay, the first element is not repeating, then we can say this is a functions. Okay, first one is a first one is a function. So if it is a function, we have to write domain. So what is the domain we are having here? Domain is the first element. All the first elements will be written in a. So here 2, 5, 8, 11, 14 and 17 are the domain. 11, 14 and 17. And the range is what? Range is the second element. The second element. So all the second element are the range. Okay. All the second element are the range. Okay, so we are having only one here. Okay, one is repeating, therefore range is only one. Okay, range is only one. So function is about we have to see the first element. Function is about the first element. So first element is here. So first element is not repeating. If 2 is here, then again it is 2, then it is not a function relations. Okay, understood. Now we come to the second problem here. Now we can find the second one. So here 2 is here, then so this is also function relation. Don't here 2 is also here, 2 is also, don't say that, but this is the second element. Function is about we have to see only the first element. Okay, no first element is repeating. No first element is repeating. Okay, then for this is a function relation. The second one is also a function relation. Is having a function relation. Then what is the value of a domain? So domain is first all values will be the 2, 4, 6, 2, 4, 6, 8, 10, 12, 14 are the domain of f function relation. And what is the range? So range is are about 1, 2, 3, 4, 5, 6, 7. Okay, the second elements of here given the given set. And third one is what? The third one, the first element, you just see first element. Okay, the first element is repeating here. The first element is having two relation. Okay, the first element is having here. So we are having the two relations of the third one. You just write. So here in the third one, we are having two relations of first element. We are having two relations of first element. Therefore, we can write it is not a function. It is not a function. So we need not to worry about it is not a function, then therefore we don't have a domain and range values. Okay, then now we'll be going to discuss the second problem. Okay, now we'll be going to discuss the second one. So second one is given. We need to find domain and range of the following real numbers. So here f of x is equal to minus x given. This is modulus of x. So the minus is given outside. So when minus is given inside, then it is a negative number will be become a positive. So here f of x is, if modulus of negative number given, it is a will be get a positive number. But here minus is given outside. Okay, in the second problem, so f of first one, f of x is minus is given outside and x we have to write. So then what is the domain and range? So here domain is what? So domain is what? It is a set of all real numbers, because x is given, which are countless. It is a set of all real numbers, because here real number is given. Okay, then set of all real numbers. What is the range? So range will be having, when we put the value of, uh, x is equal to 0. Okay, when we put the value of x is equal to 0, will we get the maximum value of 9. Will be get the maximum value of 9. So therefore here we can say, so for range is between, so from here this side, from the okay, range is infinity to 9. Okay, range is infinity to 9. Okay, end value we know, starting value is we don't know, end value we know. So therefore range is infinity to 9. And third example we need to find, so f of x is given 2x minus 5. So then first we need to find f of 0. Means what? We have to put in a relation x is equal to 0, 2x minus 5. When f of is equal to 0, means f of 0 is here 2 into 0 minus 5. Therefore f of 0 will be getting a minus 5. So f of 0 is minus 5. And what about the second one? So second one is f of 7. So f of 7 is what? 2 into 7 minus 5. 14 minus 5. 14 minus 5 is 9. And third one minus 3. So third one is minus 3, means f of minus 3 is what? 2 into x. So this relation I am calling 2 into x is 2 into minus 3 minus 5. 2 into minus 3 minus 6 minus 5. Then we are having minus 11. Okay. So this is over. Now we come to the fourth one problem. Fourth one. So fourth one is given here, uh, temperature maps, which maps at 10. Here the maps words come here. So mapping means what? It is a function. So the fourth one is given a temperature relations. So temperature relations 9c by 5 32. Okay, then we have to put t of 0. T of 0 means what? We have to put a 0 value in the c. Okay, so 90005, then we are having 32 here. Okay, and the what second one is t of 28. T of 28 means, so in the equations 9c divided by 5 plus 32, in the c we have to put 28. 9 into 28, 5 plus 32. Okay, likewise you find all these values. Okay, this problem is very given a simple. Okay, and then fourth one is might be interesting. So the value of c we need to find, right? Okay, value of c need to find. Then t of c is given. So t of c equation is 9c by 5 plus 32. Here the fourth one is t of c is given 212 and 9c by 5 32. So here we need to find c. So 212 here minus 32. 9c by 5. So then minus get minus minus do minus here, we'll be getting probably 180. 180. Okay, 180. So 180 into 9c by 5. So here c value, what c value will be getting a, c is equal to, here 5 will come this side, 180 into 5 divided by 9. So you simplify this one and we'll be getting the c value. Okay, now okay, fifth one, we need to find a range of the each following equations. Okay, this problem is very simple. You just try to solve this problem. Okay, and write the range. Okay, here real number is given, all x's belongs to real number. So means what? The first one is a set of all real numbers. We don't know x is greater than 1 means the 1 2 3 4 5 it goes, which are countless means it is a set of all. The first one is a set, range is a set of all real numbers, set of all real numbers. So second one is what? The second one, if you put value of 0, when 2 will be having, means the will be having infinity to 2. And here x is equal to 0, then it will be 0. Then third one is a set of all real numbers. It is a set of all real numbers. Okay. Now the one more important term I am going to discuss here. Suppose if any equation, suppose f of x is given x square plus 3x plus 5, x square minus 5 plus, okay, the function is given in a ratio. Then here, what is the domain values? So what is the domain value? Then domain value will be getting here by solving these denominator terms. Okay, x square minus 5x plus 4 is equal to 0. Then you solve this equation. This is 4x square. So 4x square means what here? So 5 we have to get means minus 4 into minus 1. Okay, then we can write minus 5x as a in terms of minus 4x minus 1 into x plus 4. Okay, x, take x common, x minus 4 and minus 1 is common. Here there will be get x minus 4 is equal to 0, and x minus 1 and x minus 4 only one value we have to take common value, x minus 4 is equal to 0. Here we'll be getting x is equal to 1 and x is equal to 4. So means what? Here the for this function the domain values are 1 comma 4. Okay, 1 comma 4. Okay, this point, this type of problem is usually asked in many times in examinations. Okay, now we have completed this uh, second chapter. So second chapter contains about Cartesian products of sets, relations and functions. Okay, you try to solve miscellaneous exercise and miscellaneous examples also. You go through the miscellaneous examples and try to solve the miscellaneous exercise problem. Okay, in the next class we'll be going to start with a new chapter, trigonometric functions. Okay, thank you for watching. Hit the bell icons for the notifications. Please do share your friends and make a like of this video. Thank you.